Hello everyone. In this lecture, I will show how could we apply the KCL for solving different circuit problems. Okay, like this circuit I have considered here is a very simple circuit having a voltage source 10 volt. The impedances or resistances are given 1 ohm, 2 ohm and 4 ohm. And your question is to find out the current value, this current I, okay, which is flowing through this resistive part or through this resistance. Okay. So, find out the value of I. So, by applying KCL, how could we solve out the problem? So, let me explain the problem. So, first of all, we know that there is a node and there is another node. So, all are the nodes, these all are the nodes. Okay. First of all, you have to consider whenever you are supposed to apply the KCL in a circuit, at that time you have to consider any one node of the circuit as a reference node or ground. Is that clear? That is the mandatory condition. Whenever you are supposed to apply the KCL in a circuit, at that time you have to consider any one node as a reference node or ground node. So, here this node has been considered as ground node, where potential is 0 volt, that is 0 volt potential here. Okay. Now, if you find out the voltage at this node, say it is unknown node. So, say its voltage at this node is say Vx. Let me consider the unknown voltage at this particular node is Vx, that is the potential at this unknown node is Vx. Okay. So, once you can find out the Vx here and another voltage is there for this total branch, if you consider this total branch, at that time the potential at this node is Vx, another potential at this node is 0. So, we know the total potential difference for this branch equal to Vx minus 0, clear, and the current which is flowing in these directions. Okay. So, the current which is flowing for this branch equal to, we know, potential difference divided by resistance or impedance of that particular branch. So, if you get the potential difference, that is Vx minus 0, then this potential difference will be divided by the impedance of that particular branch, that is by 4, then you will get the current I. Now, question is that how could we find out the Vx for this node? Now, apply the KVL for this node. So, already I have told that always maintain this prototype, that current entering currents will be considered as positive and outgoing currents will be considered as negative. Okay. Otherwise, you will be confused with the sign. Okay. Now, here for this branch, so let us consider all the currents are entering to this node, all the currents. This one is a branch, this one is a branch, this one is another branch, this one is a branch. So, 3 branches are there. So, let us consider all the currents are entering. Okay. You can consider the currents are outgoing, there is no harm, but for easy solution, so easy understanding, we are considering all the currents are entering, because current's direction is not mentioned here. Okay. Current may be flown in these directions, may be flown opposite directions, but we are considering all the currents are entering in a particular node. Okay. So, all the currents are entering here. Okay. So, what is the potential difference for this branch? So, here it is Vx, and for this branch here it is 0 and here it is plus 10 volt. Okay. So, the potential difference will be 10 volt minus Vx. As we have considered current is entering, that means that current should be generated from this branch which is entering to the Vx. So, obviously, that potential should be greater than that of the potential at this node. Okay. Then only current will flow, because this is very natural behavior of the circuit, that current will always flow from the higher potential to the lower potential. As we have considered that current is entering from this branch to this node, so obviously you have to consider this potential should be greater than that of this potential, which is unknown to us still. Okay. So, what will be the entering? First of all, we have considered entering current, that is why sign will be positive, plus due to entering current we should consider positive sign. Okay. Then consider the potential difference for this branch, that is 10 volt minus Vx. Why 10 volt is greater? because we have considered current is generating from this source. Okay, that is why 10 volt will be greater than that of Vx. Okay, this is the potential difference divided by this impedance, which will give you the current which is flowing through this branch. Okay, this impedance or resistance is 1. Is that clear? Any doubt? Okay. Next, this current is also entering. Okay, that is why we should consider again positive sign. Okay, so potential difference of this branch will be, what will be the potential difference for this branch? That will be 0 minus Vx. Now we can say that, sir, we know that this potential is always 0. So obviously Vx should be greater than 0. I admit, but the thing is that we have considered the entering current, that means the current is generating from this 0 voltage, although it is practically not possible, but still for maintaining proper sign we are considering that current is entering, that means it should be generated from the 0 potential. Okay, so what will be the potential difference? That means 0 minus Vx by this impedance. So this is the potential difference. So this potential difference for this branch will be divided by the impedance of this branch, that is 2 ohm. So this is the current which is flowing from this side to this node. Clear? So ultimately if you consider this thing, so what is happened? That means minus Vx by 2, ultimately minus Vx by 2. Why it is minus? It does mean that practically current is not flowing from this side to that side. Rather, current is flowing generated from Vx to this side, that means outgoing current. So in case of outgoing current, we should consider the negative sign. So ultimately we are actually considering this negative sign, that is practically current is outgoing, but to maintaining our prototype, that is we have already considered. Okay, that is why we are considering 0 minus Vx by 2. Is that clear? Okay. Now, so this is the current. And another current, this current. So this is outgoing current, so that is why it should be considered as minus sign, outgoing current, minus sign. So if minus sign is there, what will be the potential difference for this branch? Obviously now current is generated from this side, so obviously this node voltage should be, potential should be greater than that of this node potential. Okay, so that is why we have to consider Vx minus 0 divided by 4. So this, the sum of all the currents in a particular node equal to 0. From there, by solving, we can find out Vx equal to 40 by 7 volt. So now the voltage at this node equal to 40 by 7 volt. Okay, now you got the value for Vx, you know the value for this node which is 0. So what is the current now? So I equal to potential difference, that is 40 by 7 minus 0 divided by impedance of this branch, that is 4. So ultimately it is coming as 10 by 7 ampere. Is that clear? So in this manner, by applying KCL, we can solve out such kind of circuit problems, and this type of circuit problems are very frequently appearing in GATE or any other competitive exams. Okay, so you have to minutely follow the procedure which I have shown here. Okay, so it will help you solving in different types of problem. Now you can say that this problem can be solved with the help of KVL also, because apply KVL here and apply KVL here for this second loop. Okay, after that solve out these two equations and find out different currents. Okay, two branches currents for these two loops or two branches, whatever. Okay, so that can be solved by KVL also, but KCL is another unique technique which can be applied for the same circuit to find out the unknown current parameters. Okay, and sometimes it will be very easier to apply KCL instead of applying the KVL. Okay, so by another example again I will explain the matter in my next lecture. Okay.